Here's another example where you are using only Ohm's law and Kirchhoff's law. And this circuit is not a simple series circuit or a simple parallel circuit, as you can see here, or maybe I should explain that there are more than one combination. Let's usually we start here. This is node number one, and then there is another node that goes like this, and then there is another node that goes like this. So we have three nodes in this circuit. Obviously, you can see here that between the green and the red nodes, there is the resistors R2 and R3. They share one node on one side and another node on the opposite side, which makes them two resistors in series. Obviously, when two resistors are in series, their voltages are going to be the same, meaning that V2 and V3, whatever the values of the V2 and V3 are, they should be the same. However, that's not the case for I2 and I3. Because as you can see, I total, which is also I1, that goes into, I2 and I3, which makes I total equals to I2 plus I3. Now, in this case, let's type in the known values that we have here. So let's start with I total is going to be 280 milliamps. And then we're going to have a voltage supply of 48 volts. And we are going to have a 400 ohms as R3 and also 50 milliamps for I3. Those are the values we have. And as usual, we're trying to find V equal I multiplied R, Ohm's law. Possible application in this case, you probably can notice that this R3 here has a couple of values that we can use to calculate the third value. So we know R is 400 for the third resistor, I is 0.05 amps, which is 50 milliamps, and that's going to help us calculate V3. And in this case, it's going to be the multiplication of 0.05 and 400. And the answer to that calculation is 20. So 20 volts is V3. As I said before, since R2 and R3 are in parallel, that is also the value of V2, 20 volts. We have established a few things. So this is 20, this is 20, and do we know I2 here? Do we know I2? Well, according to the previous note, I said I total, which is also I1, because I total is passing through I1 in its entirety, is equal to I2 plus I3. As you can see, what's happening is this current is going here and branching here. So I total equals to I2 plus I3. We know I total to be 280 milliamps. So 0.28 equals to I2 is our unknown plus I3 being 0.05 amps. So I2 then equals to 0.28 minus 0.05, which makes I2 equal to 0.23 amps. That is to say 230 milliamps. All right. So we have I2, it is 230 milliamps. Obviously, now we have two values here of which we can calculate the third according to Ohm's law. All right, so for R2, V2 equals to I2 multiplied by R2. V2 is 20, we calculated that. I2 is 230 milliamps, but I'm going to always use 0.23 amps. The amp format is the most important. Then R2 is equal to 20 divided by 0.23. And that means R2 equals to 86.9565. So you can basically say 87 ohms. That's R2. All right. So now we're left with, we calculated R2, we're left with the calculation of R1. Let's put in 87 ohms here and see how we're going to calculate R1. According to Kirchhoff's law, in this loop here, we have the 48 volts generated as EMF, electromotive force, and it has to be consumed by R1 and R2, meaning that our 48 volts has to be equal to V1 plus V2. We do know V2 equals to 20. That's something we calculated. So V1 is going to be equal to 28 volts. Now that we have V1, we can use V1 equals to I1 multiplied by R1. So 28 equals to I1, that is the I total, which is 0.28 amps multiplied by R1. So R1 is going to be equal to 28 divided by 0.28, and that is equal to 100 ohms. And that's how we calculated R1 and R2.